Now here, with this x being equal to -1, we haven't stretched it at all, but we have flipped it over the x-axis. So if our vertex is -4, 1, I'm going to plot -4, 1. Oops. There we go. And now that pattern of up 1 over 1 is flipped. It's now down 1 over 1, down 1, back 1. So it's just following that as if it was flipped across the x-axis. So that's -3, 0, and -5, 0. Okay, so if we normally went right 2 from the vertex, right 2 up 4, now we're going to go right 2 down 4. And back 2 down 4. And that's -2, -3, and that's -6, -3. So without me explaining it, right, just going through it and doing it, it can be really, really fast as long as you're following the truth. Word of warning, highly recommend that you always double check when you're doing this process. Always double check real quickly and just say, okay, if I plug in -2, -2 plus 4, 2 squared is -1, -1 plus 1, or sorry, -2 squared is 4, -4 plus 1 is -3. Okay, good. So it's always good to just like double check real quickly with some of your points, probably the more extreme points, just to double check that you've followed that pattern correctly. All right. Notice a couple different A values, and we're going to talk about how that works with this shortcut, because really all we're practicing here today is like a basic sense of quadratics and parabolas and how their graphs work. And so that's really all we're focusing on today. So we're just going to practice that pattern and how we know the behaviors of parabolas work. Vertex, go ahead and tell me. Vertex is -1, +3. So I'm going to go ahead and plot that one right here. So then this A value, the A value is really telling you how to multiply your Y values from your 5 key points, right? When A was 1, our 5 key points from this like shift to our vertex now being the XY axis, and our vertex being the origin, we would shift that perspective and say, okay, well, this would be 1, 1, and 2, 4. And we're just multiplying our Y values by 1. Whereas here, we also, with -1, multiplied all of our Y movements. Maybe that's a better phrase to use, a Y movement, by the A value. So we went right 1, but we went now down 1 as opposed to up 1. So we multiplied our Y movement by our A. So multiplying our Y movement by a half, we know that if we shift our focus, we would have our origin here with our XY axis, and we would go right 1, but instead of going up 1, we would only go up a half. And that's true with this as well, which means we could also go right 2, up 2 by multiplying that 4 movement vertically by a half, bringing it down to 2. You could also go back 2, up 2. That's going to be 1, 3, 4, 5. And then -3, 5. I'm going to go ahead and keep these 0.5 values just because I think that they are valuable. Although we could also do a third point and we could go right 3, and instead of going up 9, we would go up 4.5. 1, 2, 3, 4.5. Just multiplying that 9 vertical movement by half. Back 1, 2, 3, up 1, 2, 3, 4.5. So that is some of key points of your parabola. I'm going to label this guy as 0, 1, 2, 3.5, and this guy as negative 2, 3.5. I am then going to connect my dots. Notice that it's a much wider parabola, that it looks a little bit fatter. So that's just because our A value is a half, which means we shrunk vertically by a half. And we noticed that pattern happening as we took our vertical movement of 4 and turned it into a vertical movement of 2. We took our vertical movement of 9 and turned it into a vertical movement of 9 divided by 2, 4.5. So you can see that that's a vertical shrink of what's going on. We're still moving horizontally in the exact same way, but this is the pattern, the behavior of the points, and why we call it a vertical shrink when we've got an A value less than 1. Versus having an A value more than 1 would give you a vertical stretch. Last one, here we go. We are going to complete the square. Go ahead and do it quietly on your own, as I'm about to do here. My bad. I did not factor out a 2 from the 4, which means that this is why we should be using pencils instead of pens. Okay, there we go. All right, vertex is 1, 1. I am going to put my axes fairly in the middle. I'm going to put my x-axis again actually towards the bottom because I know I'm being stretched vertically in a positive direction by 2, so I know that most of my key points are going to be higher up on that y-axis, was my thought process there. 1, 1 is our vertex, and now we're going to talk about our vertical movement being multiplied by 2. So if we kind of shift our focus and imagine this now being our origin, we normally went right 1, up 1, and now we're going to go right 1, up 2. We could go back 1, up 2 as well. So that would be 2, 3, 0, 3, on 1. Also, we could go right 2, up 8 instead of 4. Should have put that x-axis down just a little bit more. Well, and then I'm going to connect the dots. And that is our parabola. Notice that it looks much skinnier, but it's been vertically stretched. We can see that with these points, how our movements have been doubled, but only in the vertical direction. So that's what we mean by a vertical stretch. And so this is kind of bringing in what you learned about last year with your transformations, as well as what we've been learning this year with factoring, what you know about previous units in terms of graphing. So hopefully kind of all coming together and seeing it all work. Good job.